Pretty slow. I'm not sure how many people can use it in No?
So, were you all able to download this data? No? From here? Oh, you're just passing the USB? That's fine.
It's not working?
It's connected, but
Maybe it's
the data.
it shows full connection. Maybe it's just not. Yeah, it's pretty slow.
Okay, I suppose you all have R and R Studio installed, right? Everything, so that's it went through fine, and you didn't have any issues on. Okay, that's great. Okay. Um, so let's get started as we upload the data. Uh, this is an excellent book. Okay, R for data science, and this is the course material that I would be teaching from. But although in the fall it will be streamlined towards biomedical informatics, clinical informatics. So this is kind of different from the bioinformatics and next-gen sequencing. It's more or less an introduction to data science, or empowering people, to do data science rather than actually doing data science. I mean, data science requires much more intense domain knowledge, domain-specific knowledge to do that. Like, but then there are certain principles and methodologies that one can follow. Like there are routine principles of selecting the data, or grouping the data, and visualizing. Right, some of these things are common across all streams. So the emphasis on the course is to actually empowering people to do data science, regardless of where the data comes from. Although our focus is, since the program is biomedical informatics, it's going to be through the informatics data. One of the largest data repositories of the data science, the clinical informatics, is a data called MIMIC3 data, MIC3. Okay, so the course will be more or less streamlined towards the MIMIC3 database. Okay, so this is what we are going to focus on the course. So one of the data sets that you are now passing, it's from the MIMIC3 database. It's a huge database. It's about 50,000 patients collected, 40,000 patients collected across 10 years in Beth Israel. So it has a large amount of data relating to ICU. So one of the data sets that we will be seeing today is from this database. And also there is another big data source called HANS New York. So this is for New York City's database for public health. So this is another a big data source for New York City's health and nutrition examination survey. So this is one of the database that we will be focusing on, taking data from here and doing some data science over this course. And today's workshop is organized towards just getting a hands-on, getting a feet wet on doing data science using R. There are different lines of thought whether one can use Python or R. Both are good. Python is a more full-fledged programming language, but equally R offers several other competitive packages, and it's an open source, and especially when it comes to bioinformatics and biomedical informatics, it has been extensively used, right? I mean, so that's why we thought we should focus on that. And one of the key paradigms in doing data science is this. most of the real world data that you see, right, it's going to be messy. Most of them will not be as nice as we would expect, and you will see that most of the time when you look at the data, it will be handling the missing data, how to normalize it, and so a bulk of effort would go into actually making a data neat for doing analysis. So this part of it is called wrangle. Actually, that's the paradigm here is to explore, wrangle, right, and then model, visualize, right, and model and then program and then communicate, right. So first we have to import the data into this program R, and then we have to tidy the data up, and then we transform it, right, wherever whatever that's necessary, and to do the modeling and things like that. But one of the critical aspects of what I found of doing data science or data analysis is communication. Like most of the time, we will have a code in one area and the program in another area. Like if you visit back after 15 days, you'll forget what you have been doing, right? So that's the critical aspect of doing data science that's been probably, probably missing, and R has an excellent way of integrating these two. It's called R Markdown. Okay, so that's where we will start. We'll start with communication. I think that's the key aspect. I mean, the agenda in this book is the communication comes in the later part of it, but I think the emphasis for communication should be the first one, because most of the time you will not be just doing the analysis for yourself. You want to communicate your analysis to your peers and your managers, right? So that's one of the key things, is to communicate. So R Markdown, and I think Python also offers a similar thing called Jupyter Notebook, right? So it's similar to that for R. So what we are going to do is start with R Markdown, they communicate. And then we are going to take the data and do a data analysis on it, and then try to infer some meaningful patterns in the data. So that's the agenda for today. Okay, so that's what we'll do. If you go to the R for data science, are you all able to access the internet in here? No, or not yet. Okay, but let me. But you have R Studio, right? So just go to R Studio. Okay, I'm going to make this. So you will see the 4 panels here, right? If you have worked on R Studio before, this is an environment panel where you can see the data, and you have a history of commands that you type in. So this is the main console panel, which is on the top bottom here. It's you will see the left bottom here. You see the console panel, and this is where you can type in whatever commands that's required. Console, yeah. So I think the first thing that we want to do today is install what is known as a tidyverse. So what you do is type in. Let me make it a little bigger here. Zoom in. Oh yeah, that will be best. Hopefully. Oh yeah, that might be good. Yes. The first one. Okay. Is it better? Right? Let me make it even bigger. Okay, so this is the console panel here, right? So you can type in the commands. Like for instance, the first thing would be to install for our purposes today packages tidyverse. But I think you should have a connection to the internet to install it, right? And, does everyone have this package? No, right? I mean, it's but what we can do is if one of them can download this package, I can download this. Or who has internet here?
So I don't have internet. If anybody wants to tailor with the
Okay, actually you can.
I think if a few people use it at one time, it should work. Like those who are done using can disconnect.
So let's do a workaround here. We can go to tidyverse. Tidyverse. So if you, okay, so in CRAN, whoever has internet, if you can download this gzip file, right? Who has Windows and who has
Windows.
so okay, so we need to get both the window as well as the OX.
In the download?
Yes, it should be in the CRAN. Just go to Google and type in tidyverse, TAR package, the TAR package. So this guest should work. Technically, this guest network.
My downloads are working. I should have it.
Oh, yours is working?
Yeah, I'm doing it from my phone.
Oh, okay.
I might have a pen drive here actually.
The tidyverse, right? The tidyverse. Uh, who has Mavericks or does anybody have LCAP? LCAP? You have LCAP, then. But you can just download through your network,
Yeah,
right? Okay.
and I can see if it comes on the pen drive. If a few people have
So otherwise, I think who has Mac here?
I have Windows. I can download it from Windows.
Oh, okay, that's fine.
I'm doing it for now.
Okay.
Do we need the developer version or the other one?
The release version should be good. Does anybody need Mavericks?
Anybody has a flash drive and no? I don't have the Mac. No, thank you.
That's okay.
So if they click on that, modify the shape.
Okay.
The tidyverse pack. You already downloaded? Oh, actually, if you have a network, you can just go in and type in install.packages tidyverse. It should get that
This is
the package.
version.
Sorry, yes. Yes.
So we have to
Yeah, that's fine. Right. Yes. Yeah, if you have internet connection, just go to console and type in install.packages tidyverse. You should be able to get that. It would automatically download and install it for you. It's for only those people who don't have internet connection. We have to, manually install it from the. So yeah.
The window version of
Oh, I don't have it, but I can copy it for. Well, I can copy it from my computer. That's the problem.
I can copy, but how do I find where the?
Oh, you can just download it from the. Well,
I downloaded it.
oh, okay.
How
go
do
to
I
the
find it?
downloads.
Yeah, go to
Oh,
downloads.
I mean, I typed it here. So it's downloading the different packages.
Oh, you downloaded
In the
R
Studio.
Studio. No,
I cannot.
no,
Okay.
yeah.
So what do I have to do?
You can actually go to
Tidyverse.
yeah, tidyverse star package TAR R yeah package. Oh, you copied it the folder. So go to once you have copied it, go to this packages in your R Studio. It's in the and then go to install.
Which one do you need for? El Capitan or Maverick?
What is
Oh, what's your computer?
OS version.
Yeah, yeah,
No,
but
which
what's the?
version?
I think it should be the Mavericks probably. It's 10.12. I think it's El Capitan, right?
Should be.
El Capitan. Yes.
So you need this, right? The
Yes.
binaries. This one? Need this file? Or the
Yes.
packet source?
No. This one.
This one.
Yeah. El Capitan. Sorry, guys, for this trouble. It's. I mean, the network has been crazy. I don't know what's happening with the IT people here. It's.
It's the same in all institutes.
Yeah. I mean, they.
The IT people in all institutes are amazing. Which site? I'm downloading the binary for whatever version you need. You go down, so you're on cran.r website, right? Just go down on downloads and then you'll see various links. It's tidywords.1.1. Yeah. I'm doing the math. Just give me a second.
Yeah. No, I think it is just download and then after it download only two versions. One for LCAP and one for Mac. Nothing in between.
no? I don't understand.
Oh, that's fine. Oh, and there is some other tool that we need to copy as well. It's called RCA. That's the R tool. Install.packages. But I think 6 of them will be able to connect at once, right? Why don't you just once people
I'm unable to start.
once people are able to get the data, get it, then
we don't need archive.
yes, we need R curl. So if you can download R curl and then sign out of the link, the other people will be able to connect them.
Do we need to download any other stuff from?
No, just these two, the tidyverse and R curl. So these are the two things that we need for today. I mean, if the network is
Do you need the zip file or the unzip? Zip? Yeah.
Oh, okay. Not through the linear network. So
There are two big files. One is named as Windows. You see that.
now you can actually sign off from the link comes with immediately. I think they have to do it.
What was the other package you were trying to get?
Or so.
Oh, you have that file? Okay, that is hard. Let's go and package. Install package.
Yeah, that's what I'm trying to do.
Okay, let's do this.
You should do that. I hope I don't have it. Okay.
Thing that we downloaded could have been for 3.4.
So those who have those two packages, both the tidyverse and rcurl, you can sign off. It will be good for other people to get connected.
If anybody needs Oracle, I downloaded the Windows and as well as the Mac version. You can use it, I have it. But I need a flash drive. Okay, so
All hooked up.
I think the best way is to use it and just wait till we will try to
Yeah, that's fine. But this R, okay. Oh, even if you have this, everybody has this data downloaded, right?
That's what
So,
I was saying. We don't need an
okay, so that's fine. But tidyverse is important. Everybody has tidyverse? Okay, no? Who doesn't have tidyverse? You? 1, 2, 3. Okay, so if everybody can log off from Emily's network, then those people will be able to connect and download tidyverse. Who's still on network? We don't need network anymore. So it should technically work. The guest should work, and it says that the connection is successful, and it used to work. I mean, I have been using the guest, but it doesn't. For some reason, it says connection, but then it's not going through. It's strange, and why you know. What does it say?
It doesn't give me tidyverse.
Are you connected?
Yep.
Which version of R are you using?
Did that work for you? No?
Who has this tidyverse package? They have
It's for L.
Oh, I think this is. That's good. You were a bit, no, it doesn't install for you? What is that?
Oh, maybe I'll connect with it.
Can you just connect to internet from my phone?
I have also had the same problem with that. The archive should be on the one of that.
Oh, it's. Yeah, it's installed.
I don't. I might be wrong. No, they could be first time. I think the one that I counted it was Windows. It was Windows. Yes. I don't think we need R code if we have already downloaded the data. We have the data.
Oh, yeah.
We needed R code just to download the data.
Oh, okay. So looks like tidyverse doesn't install on certain.
Through this, right? Because it will have some dependencies.
No, it doesn't. Even online it won't.
I mean online still it's not.
What does it say?
It's like it's a version dependent. So it's one for Mavericks and other for
And you have
in between those two.
okay.
But ideally it should work, right? No, it's not installing. Do you have internet connected? Yeah.
Oh, it says R and R Studio has incompatibility with your.
Can you there's another way of installing your R studio.
Like install
So do we really need these?
No, don't browse.
You want
You
to
have it
install
once, right?
resources of packages which will come.
Type tiger version. Okay.
Oh yeah.
You need these, right?
Right, yeah.
Oh, wait.
No, change
Sorry.
this, change
We need to change the source. Like your installation can. Now type tiger version.
I think it has to do with the your original path. It's not an R problem. It's the place you are, because this is a strange error, like unknown input format. Right?
Do you have ggplot and other? This is actually incorporated.
No, she has internet. There's something
Oh,
else
yeah.
happening there. It's not even
Well, I'm
installing
having
from our
trouble
system.
installing tigerverse because I already have some of the packages compatible.
Unknown input format.
If you have ggplot or uplier, then it might be like it might be conflicting with the tigerverse.
In addition to this, we need to
I don't think we need the answer.
Okay.
I think you have to transfer it on our system. Oh, you have to download. Did you download it?
yeah.
Yeah, so I think you have it saved, right?
Yeah.
I'm just done. I did a course in
Yeah,
I
looks like a familiar face. In Kannan? Oh, don't go to Kannan.
Oh, I got it confused.
Yeah.
want to try And with DevTool and GitHub, it's for the same. I don't think it's. See, I think her problem, her computer has an issue where the R package is downloaded. So rather than, so it is.
That's the newest.
So this says you can install tidyverse from GitHub too.
That's the problem.
I'm sure it's the same.
Yeah. No, that's not. See, the problem is even if you try to install, right? Like what developer tools, right?
DevTools.
Right. So, for instance, I think it's already DevTools. I think might be installed. See, see, it's not even able to develop. So I think it's an issue with your.
I'll write it.
Uh, yeah, I think for,
You can just share a computer.
it's. I think it has to do with your directory where the things are already installed, and I have to delete that, like all the R data in there.
Or and then you install it
Yeah,
somewhere else.
yeah.
Or-
So I think it would require much more work.
Okay, so I think we can stop the.
Okay. I'm sorry.
That's okay. Oh, that's what.
Okay. All right. So everybody has this tidyverse package. Okay, that's great. Okay. Sorry, it's the network is a. I think I'm going to complain to them. I mean, it's crazy. I don't know why. All right. Let's go ahead. So our Markdown, right? It's a neat package for communicating, right? I mean, for communicating your analysis. So you can go ahead and in your RStudio, just open a file, go to File, New File, and then you can choose any of these files. So choose R Markdown. Okay, so it's.
If you are using it for the first time, you will need it.
Which one? R Markdown?
Yes. If you're using it if someone is using it for the first time, it will require internet.
Does it say that?
Yeah.
You should be able to get this.
Let me add another iPhone network so that you guys can connect it.
Guest is working?
Is it?
Oh,
So which guest is this?
NYU LMC guest.
Okay.
Can you browse anything?
No, I can't.
It would say that's successful, right? It says the connection is successful.
Go on a website.
But if you go to a website, it doesn't connect.
It's the same thing. Alright, I think you might have a slightly. You have a different Windows version, right? It might be working for you. I'm not sure. I think she has Windows. You have Windows 8?
No, I don't think it's not the OS. It's something screwed up with their system. I
No,
mean,
but it's working on Windows 7 or Windows 8, but it's not working with Windows 10.
the LMC guest?
So,
No. She might be connected through her Kerberos ID, right?
okay.
It might take a long time to get to the understanding.
Sure. Yeah. Okay. I mean, that's fine. I can demonstrate. That's not going to be a problem. But okay, let's do this. Let me go ahead and start this, and then just go over it, and you can watch it, and maybe it's also recorded, so I can put it on, offline. So our Markdown, right? You just need to create a Markdown file first, and then it's going to make up a Markdown document. So what this R Markdown file facilitates is that you can do all analysis that you want in here. It's going to be recorded, and simultaneously you can actually infer, view the data, and the code and the analysis is going to be at one place. So it's a highly reproducible format. So for instance, the R Markdown file consists of these. These are YAML headers called test and HTML document. It says that it's a HTML document. And the R code, right, the chunks of code are written in this format. It has to proceed with 3 quotes, it's not quote, it's the tilde symbol. The first one, it's a single quote. What is that called? Character. Forgot this character name. And with R, and then a name for it. You can give whatever that name you want, and then lots of flags in here that you can set it up, and then this says that it's a knit R document. So and then it's going to echo it's true. So basically, what it does is this generates a set of HTML HTML documents. So let me see. Let me show you this. Okay, so once you you can need to HTML. Okay, so it's going to ask for a document. So you can say test, and it's going to make an R markdown as an HTML. You can even write your CV in this. Actually, it's a very powerful HTML generator. So R markdown's a test file, right? So your code and everything that you can write, it's going to be in one place. So basically, you can include all text in it, right? I mean, you can generate all text in it, and there are some formatting options for italics. You just start with a single star is an italic, and a double star is in bold. So, for instance, if you go here, and then if you type in this is a test, let's say. Single, it's going to be generating in so this is going to be generating in a italics mode. Okay, so you can have everything together on this. Now, one nice thing about our Markdown file is you can run your code just in this code chunk. Okay, so these are called code chunks. Okay, so for instance here, this actually is a R chunk. This is named cars, and car is a data already, the data that's present in R. So you can run this data here, and immediately you can see the output here. So instead of seeing it in console, you can just see it in the editor here. So that's what, and you can even generate nice pictures right here by running this code. Okay, so R Markdown is one of the very powerful tools for communication. Your code can run into it, as well as the data can go into one big file. So you can generate all of these things. So today what we are going to do is use this R Markdown, and then we are going to generate some of these. We are going to study this data set that you have downloaded. Yes, you have downloaded, right? So this data table is called input events. Okay, so you can take a look at that this table. This is a table that I was telling you about, the huge data repository, right? So you can so this is the table that has the patient subject ID, ICU, and what type of medication that the patient was given in ICU. So it has all this information related to that. Okay, so this is just this is like 170,000 data variable. It's a huge database, but I only extracted like 1% of the data, and that amounts to this. So what we are going to do is we are going to explore this data set, right? This is this data, my data, and we are going to go over to see that if we can maybe if we can identify any useful pattern in this data, right? So what I'm trying to do here in this code chunk, right? So I'm just downloading it, and that's why you need a rcurl package. So install.packages, right? That's going to install whatever packages that's available, whatever packages you wanted to get it installed. And library rcurl means that it will load the library. So in R, you need to load the library first. whatever that you want to work with. So here I'm downloading, I'm loading this library RCURL after I install it, and then the data is going to get copied into my data. So it's going to read, my URL, this is going to read, and to read it, I need this RCURL. So this is going to read this data from this URL, get URL package is through R curl, and it's going to read this data into my data, right? And now I can execute this data here. So once you execute this data, it's running, it's bringing the data from this web server from GitHub, and see, you can, below you can see that run chunk. So it's going to run this chunk here. Okay, so it's done. So the data has been brought into this machine from the external server, right? So from here on, we need this tidyverse package. Okay, so that's the tidyverse package is a big package. That's essential for this. This book is based on tidyverse. So this has like lots of deployer and lots of manipulation for data analysis. It's just streamlined towards that. Okay, so we will see some of those things that you want to do once you download this data, right? So we can look at the data frame, right? I mean, as soon as you download the data, what's the first thing that you may want to do? Right? But then, I mean, yeah, but you can't, like, I mean, there are like 170,000, right? So that's one of the things that you can, yeah, like just some random portion of the data or just 5 headers, right? So that's the idea here. So display the data frame. So once we download it, we can display the data frame and see how the data looks like, right? So this is just the 5 rows and 5 columns, row ID, subject ID, and ICU stay, etc. But this doesn't give us much information, right? I mean, we may want to just look at the columns alone to see what columns are there. So that's the next typical step that you want to do when you have the data, right? So we look at the data frame. So this is done by a package called sapply. The sapply lists column headers and also the categorical variables in there. So we look into their columns of the data frame and identify their types. One of the key things that you may want to do after you download the data is to see what type of data that is in, right? Some of the data could be an integer, or it could be a nominal variable, or it could be a categorical variable, and you want to make some plots and visualize them to see what makes sense and what doesn't make sense. So the key thing is to actually see not just the column names, but also the type of the categories that they fall into, right? So so that's what I'm doing here. I'm trying to look at the column names of this data alone using this sapply, right? Sapply my data and the class. And so it's going to display all the column names. The first is the row variable, which is an integer, the row ID, the subject ID is an integer, and the factor, the chart time when they entered is the time. It's a factor. Factor is a name for categorical variables, and the rate is a numeric, right? So you may want to see what things that you can do with the numerical variables and what things that you can do with the categorical variables, right? So once you get the columns, you may want to see what actually mean. I mean, if you can plot it and see that if there is any relation between, let's say, here the original amount, it's a numeric, right? And also the original rate, let's say that it's also a numeric. And you may want to see if there is any correlation between the original amount and the original rate. It could be any other variable. It could be a categorical variable, but this is just an example to see if there is any correlation between the original amount and the original rate. And I'm running this. Okay. So this is what I get, right? So this is through the tidyverse called ggplot. Have you heard of ggplot? It's one of the very powerful plotting utility that's available in R. Okay, so ggplot actually takes the standard format is the data, and you can specify what kind of a geometry that it has to plot. Here I'm just plotting it as a point. Each of them is a point. So that's given by geom point. you can actually it could be a line. So there is also another geometrical variable for a line in ggplot. Okay, so if you type in ggplot in the console, you will see that it will give you lots of options of what are all the things that you can do with the ggplot. I mean, ggplot is huge. We can have a tutorial just on ggplot if you are interested. It's one of the amazing utilities there. Okay, so this I'm just plotting the scatter plot between the original amount and the original rate here. I mean, it doesn't make much sense to me, but then there is something that you can infer from this. What's that? What do you infer from this plot? What's something that immediately comes to your mind when you see this? Right. Most of the data is empty, right? I mean, yeah. So the data is clustered between 0 and let's say, what's that, 1,000, perhaps 1,000, 2,000. So you may want to restrict the range to see anything inside, right? So that's the next step, right? I mean, so the limits are too off, so we set the limits, right? I mean, this is very easy by adding the last one with the limit. It's done by x limit and y limit, right? It's between 0 and 100. I mean, I made it 100. You can make it 500, or it doesn't matter. But one of the things is that, I mean, most of it is empty. I mean, this is an exploration, actually. This is a data exploration, and this is how the the real world data would look like, be it from finance or from biology, right? I mean, so the next step would be to limit and then see if there is anything that you can infer from the data. So once you set the limits, right, between 0 and 100 and 0 to 500, you see something, right? I mean, so what do you get from this? Nothing could be a perfect answer to, right? I mean, you can't. Right, right. I mean, yeah. And you see that there are much more, I mean, the values of 500 are much more lesser. In fact, it's scattered from 0 to 300 probably. But you can't make much things out of it. But in general, this is the general graphing template, right? ggplot. You plot the data and the geometric function and the mapping. So the mapping could be an aesthetic map, okay? One of the things that we can now introduce is actually to see that if the coloring could give anything. Like for instance, now you don't really get anything from here, right? So try to add in another variable. Let's say that, so there are so many parameters here, right? The column names here, original amount, new bottle, stop. So what I'm trying to do next is trying to see that if there is an original route is whether it's given through an IV or it's given continuously through the mouth, or there are different types of giving the medication, right? So that's the route. So what you can try to do is that, okay, now I don't see anything meaningful here. Let me introduce another variable called the route, and then color it with the route, the original route, and see if you could make anything meaningful out of it. So that's what I'm trying to do here, to just plot it in a different color to see if there is anything that immediately puts, colors the variable according to the route, and then it gives me the legend for it. So how many of these medication were given through the mouth? How many of them were given by the drip or intravenous? So, I mean, so there are, so what do you infer from this? Right. You could see that some of them are not really present at all, right? Most of them are through intravenous or intravenous fusion or through intravenous push, right? So actually, you can try to see if there is, instead of color, some of them, there are lots of categories in here, right? So one of the things that you can try to do is actually uh, make it a transparency, and to see that if it makes sense, if you could infer anything meaningful out of this by introducing transparency instead of color. So here I'm doing it by color, right? So you can do it through transparency, and that's given by the factor called alpha. Instead of color, you can try to introduce transparency for each of them. I mean, these are just explorations actually at this point. It doesn't make much sense from here. To see that, okay, let's say that there could be something hiding in here. If the oral or some of these things could be hidden in here, that the other color actually overrides it. So you can introduce alpha to see that if the transparency would help. And so here, and also what you can try to do is you can do shapes. You can just plot 6 of them or at once, and then see that if it if you can distinguish any meaningful data in through the shape. And at once ggplot plots about 6 shapes, including the blank. Okay, so at this point I'm trying myself to find out any pattern for these original route by introducing different types of scales, right? Or what you can do is you can specify your own color instead of the default color, right? I mean, to see that if that makes any sense. So from this point, I'm not able to infer anything, right? So far, none of the plots are useful in distinguishing each of these, right? But there is something nice about the ggplot, that you can actually put a facet to it. Okay, instead of doing it all in one plot, you can make several facets to it. Okay, so the facet wrap, right? This is the package. This is called facet wrap. That's also available through the Tidyverse program, actually. So the facet wrap, right? What it can do is you can actually have you can plot each of these in a separate window. So that would be much more ideal to do here, because it can immediately tell you if there are a lot more clustered around in one of those. So here you can see that none of them, like the by mouth or drip or GU, doesn't really help here, right? So only the ones that make sense here is the cystic, feeding tube, and all these 4 of them, right? And in fact, you can add colors to the facets by just like that, right? Instead of if you introduce colors, it's going to how did that go? Oh, yeah. The thing that we need to understand actually is, if you leave a space between the 3 quotes and R, it's not going to show you the run icon here. Okay, so that's whenever you don't see it, it just means that you have a space in here. So this is just a facet wrap with separate colors for each of these. Okay, so what you can do is you can see that for each of these different types of original route, you can plot it in different colors, and we see that only these make sense here: the gastric feeding tube, intravenous fusion, intravenous push, right? So you can actually remove some of these, right? So we are slowly getting into data analysis. We have tried slowly removing the noise out here and converging into the data, right? So this is where the data exploration starts. Okay, so this is called a deep layer package. And the first thing that you may want to do is filtering the data for only these variables: the gastric feeding tube, intravenous, and intravenous push, right? So what I'm trying to do is, it will be good actually if you can practice. I think most of it comes through practice and what you do more than me just going over it. But today it's unfortunately we don't have a practical session here. But the filter data here, right? So this is the command for it: filter my data, and the original route could be a gastric or feeding tube, or it could be a intravenous infusion, or intravenous push. Right? When you filter this data, right, you can actually you can plot it and see right away that once you filter it, and you can just plot the data, and you will see that there are only 4 variables that it has filtered out. So the rest of them are gone. You don't need them. Right? So now, so once we have a facet, this is just a facet wrap, right? It's a combination of 2 variables, right? I mean, so basically here, the facet wrap is given by the original route, and we can extract only those. You can actually plot 2 of them instead of just plotting 1 variable here. So, for instance, okay, so here, right, you just saw that intravenous, once we converged on this, right, we can now look for another category, whether the medication was stopped or not, right? So now I'm adding in another dimension to the data. So here, right, so there is another variable called stopped. That's a factor, okay, that says that the medication is stopped or not. So now what I'm trying to do is actually I'm trying to plot it and see whether there is another variable, adding in another variable to see whether the medication is stopped or not. And that can be done using what is known as the facet wrap. You can include another variable called stop, right? That's going to give me a 2-dimensional data plot. On one dimensions you have whether it's a feeding the variables in here. On the other dimension you will have the categorical variables that are in the stopped category. Okay, the stopped category is there are 4 of them. It's, I think, discontinued, whether it's non-stopped, and whether it's restarted, or whether it's absolutely stopped and there is no records in here, right? So that's one of the nice things about facet grid is that you can make another variable and then try to explore whether that data makes sense in any of these categories, right? So now we have these 4 groups that mainly consist of medication there the infusion status is not known actually, right? So far we have just explored using just a point, right? I mean, just a point. But there are other variables like you can include smooth. That would show you whether that will smoothen the data, and then that will show you here, right? I mean, you can infer something like this: the original from this, right? Which is as the original amount is increased, what happens to the original rate, right? So some of these things can be inferred using this this geometry called geom smooth instead of geometry point. Okay, so this is a very critical thing that you can actually use whether the point is better or a line smoothing is better. So it's going to take the data, and these shadows is confidence interval of smoothing the data. It's going to show you whether how far is the confidence for this smoothing operation that you have in here. So so it gives the overall picture of the data, right? I mean, we are able to find that as there is an increase in the original amount, right, the infusion actually decreases. The original intravenous infusion, right, decreases. But then, so these are called directed insights, right? I mean, this could be extremely critical when you go to an application. I mean, most of the things in data science in the real world are not complicated. They are not complicated. It is how far you will be able to make a meaning out of the small information that you have. It's about interpretation of the data. I have to have a keen eye to actually know. So this could be a very useful information that the intravenous infusion decreases, right? Which I am not able to get through if I just plot it as a point. But if you plot it as a line, you will be able to see that it increases or decreases. That kind of a continuity that it can provide you, rather than just visualizing at as a point, right? So these will be extremely valuable. Like I remember when I was doing data science for a aircraft base in Oklahoma, there are like literally 5,000 aircraft that comes in for US Air Base. It's one of the biggest air bases there. Oklahoma Tinker Air Force Base, and you have tons and tons of variables like how to refuel it, which is the best optimal way to refuel it, and there are like lots of variables. And these are some of the I gave them some of the directed insights based on these analysis, like cluster analysis, and to see how what it makes sense just by visualizing, right? You can plot it as a bubble plot instead of just as a line. You can add a third dimension to it of if there is a bigger volume, that it shows the bigger bubble it is, right? So that's one of the key things about directed insights. These are called directed insights, and you get a directed insight by just doing a smoothing through a line instead of smoothing through a point. I mean, instead of just having a point, right? So this is a critical information here. And you can actually, there are lots of geoms that are available. So for instance, you can type this and see the geometries that are available. Right? Okay, I'm going to take few geoms. See, you can plot tons and tons of these things. Like bar is a bar plot, box plot, and can have a density plot. Some of these will make sense for your data, some of them will not make sense. Like for instance, if you use a numeric variable geom for a categorical variable, it's not going to work. So you have to be selective and careful in choosing it. That's what I was saying in this book. They say that EDA, exploratory data analysis, is a state of mind. That's a nice word to use actually. It's not something that's okay. There's a pre-cooked formula of doing something, this and that, but it just comes through practice, and then the more data that you collect, you'll be able to make more meaningful information. So, and then there is this data transformation that one can do after you filter it down, right? So once you filter the data down, you may want to select, right? Select certain variables, or reorder the rows that you have to do using arrange. And these are the key 5 steps that that needs to be that usually that follows data science protocols. Like once you filter it, we already saw filtering, right? Once the data is messy, we may want to filter it, and also uh, uh, fill most of the data will have missing data, like for instance stop, right? That's how and you may want to interpolate or extrapolate those data points, right? For that, it's best to rearrange the data. So people usually arrange it through ascending order or descending order. It depends on the thing that you want to study. So the arrange is one of the key functions. So there are 5 main functions, right? And also there is this select. Once you have arranged the data, you may want to select some key variable. We will go through each of those, okay? Or you may want to create new variables with the existing variables, and that's done through the operation called mutate. And finally, you may have to collapse several variables and then summarize based on some metric. And usually the summarize function follows what is known as group by. This is one of the extremely important variable, the operation, if you ask me, when doing data science. Let's say that you have genes. You have some mutations in genes. The first thing that, to me, my question would be, how many mutations does a gene contain, right? So if you, that question could be answered by group by. Okay, so what you do is group by gene, count the mutations. So that would immediately give me how many mutations the gene contains. So group by is one of the extremely important data analysis operation, and that's facilitated by this keyword called group by. Okay, so that comes after the summarize. Usually, you want to summarize the data using group by. Okay, we will go over each one of those things. So for instance, here, right, arrange is similar to filter, except that instead of selecting row, it changes their order, right? You may want to, it takes a data frame and then it changes the order of these data. Like for instance, here, once I filtered my results, I take the filtered results and I arrange it using the descending order of original route. So, and then I want to see the top 5. Head will give me the top 7, I think. It will give the top 7. It will give the top 7 values of the arranged values. So, here. So, once what I'm doing here is after I have arranged the data, I have selected filtered the data of only those variables. What are those variables did I filter? The original rate. Yes. Right. So this data is going to contain only those variables in here, and then it's going to arrange with respect to the original rate. Okay. So yeah, only for those. See, this filter is for those variables. It's not going to filter all the columns. It's just going to select only the original route is gastric or feeding tube. It's going to, but then it's going to keep the rest of the columns. It's not going to take away the columns because filter is for the categorical variable for this the original route. So it's going to throw away the rest of the columns that not have either gastric feeding tube or intravenous infusion or this intravenous push. It's going to only select those, but then the rest of the columns are kept. Okay, so that you have the rest of these columns, but these columns are restricted only for those variables that have intravenous push and intravenous fusion, etc. The four categories that we were interested in, right? All right. Now, we want to now, after doing this, right, arrange. Once you have arranged the data, we can change the results parameter to show the data. It only shows the results, right? I mean, here you can change the results. This parameter, okay. So our Markdown has these flags, okay. These are critical flags, actually. I forgot to mention that flag here. There is a nice. Okay, so here you see that you can provide all these flags in here. Eval equals false. Eval equals false. Include equals false. These are all the flags that you can provide to the to that R chunk, and it will say if you say eval equal to false, it will execute the code, right? I mean, it will false means it will not execute the code, and it will not show the output. So you can change these flags according to these parameters here. Okay, so you can only show those results that you can change the results, right? We changed it to show only those results. Okay. Now, once you have this data, right? Once you have selected the data, right? So this, we can now do a data transformation of selecting, right, only those 4 items: original amount, original rate, and original route, right? I mean, the rest of the columns we are not interested in them, right? I mean, we don't want the subject ID or something like that, right? So this is what the select function does. selects the columns, whereas filters the row that evaluates some condition. Okay, so this is like a column operation and a row operation. The previous is a row operation and this is a column operation. Okay, so it's going to select only those columns that we are interested in here. Like for instance here, the original amount, original rate, and the original row. So these are the only the columns that we are interested in, right? And once uh, so, so so for instance here you can view by default the missing values are listed in the end, all the by descending order, right? When you change it into the descending order, it's going to show you the results only that are in the end. The NA values are listed in the end, that you can actually if you see the tail, right? I mean, if you see the tail is a command that will show you the end of the uh, columns, the end of the matrix, the data frame, right? So the original rate, you see that it's all NA is listed at the end, right? So that's how uh, so the key thing that you may want to do now is to remove all those missing entries, and that's given by drop NA. Drop NA is going to filter out all those missing entries in here. And then you can do a tail, and then you can see that all the missing values are gone here. The original rate is 0 now. Okay, so now once we have done this, the key, another key operation in data science is mutate, that you can want to make new variables, new columns, and that's given by the function called mutate. Okay, so here, for instance, after I filtered, I want to mutate this data, right, and then create new columns. So, for instance, uh, one of the things that you want to do before you do a mutate is that you have to see that the new operation makes sense. So for instance, if there is 0 here, you may not want to divide by 0, right? So the key thing is to actually remove the ones that are greater than 0. And that can be done by what? You want to see what are all the values that are greater than 0, and what operation do you use to evaluate all of the ones that are filter, right? So it's a row operation that you do a filter, right? So that's what I'm doing here. I'm dropping down all the NA results, and where the original rate is greater than 0, I'm just taking those values. So and then I'm looking at the tail to see that there are no zeros in here. I'm making sure that there are no zeros, and then now I can, let's say that I can create a new variable, right? So I can create an expected time. So I have the original amount, right, and the original rate. Now I can create my own variable. Let's say that I'm creating here called expected time, which is actually original amount by rate, right? It's like distance by time, right? Something like that. So it's the original rate, and I want to see, I'm creating a new variable, and that's given by this function called mutate, that can take the data and it can create a new variable called expected time. I'm saying that divide the original amount by divide the original rate, and just round to 2 decimal places. Okay, so this is a very useful function, right? You might have like a data with cell division, let's say that, right? You may want to make a new expected time out of it, right? So you can just make it, right? Mitotic rate or something like that. You can be creative, and you can do whatever that you want with that. It's at this point, mutate is more physics, I would say that, right? I mean, you can make your own variables and whatever that you're interested in. Now, there are several arithmetic operations that you can use with mutate. right? This one, this book, the data science has lots of transformations with doing with mutate, right? And once you have it, so let's say that you may want to group by. This is one of the critical operations, right? So here, uh, I see that all the item ID with 30013 have the same expected time of 0.07. Naturally, because the original rate and the original amount is the same for it, right? Now so you may want to ask the question, what's the mean value of an item, right? So one of the things that you want to see is that whether this 0.07 is a mean value, is every value is the same or it's different. So this can be done by the group by operation. It's one of the critical operations, right? So what I want to do here is I'm trying to see mean amount, mean rate, and mean time, right? I'm going to take the mean of it. I mean, by actually taking this grouping. First, I'm going to group by item ID. Okay, I'm going to take this item ID, right? And then I'm going to group this item ID and original route, right? I can group by this item ID and original route, and then I can take and find the mean amount, mean rate, and the mean expected time of these um, of these uh, of these grouped result. Okay, so that's the operation that I'm doing here. So let's see, let's run this and see what we get. Okay, so for instance here what I get is this. After I summarize the result by my mutated result, I'm doing it by the item ID. So for 3001 item ID, right, I could have intravenous push, or I could have intravenous infusion. So for instance, this 30013 has intravenous infusion, and intravenous push, right? And count is the number of values that are found in there. So for instance, for item 3001, there are 36 items in here, and the mean amount given is 346 and mean rate is 98. So this is all done by actually the group by and then summarize, right? These are very critical operations actually. You can do lots and lots of things with that, and I'm just summarizing the top few portions of it. Now I get kind of an idea of what item is approximately given by what mean rate and what mean time, right? So now this can be plotted for data exploration. Like you can plot now once you have it. For instance, you can actually plot the mean rate and the mean time for these. And how does this look like? So for instance, if you look at this, right, you can look at this. It says that the mean rate gets higher as an expected. I mean, so for this, let's look at this and see what does this graph tell you? Right. So for intravenous infusion, right, the intravenous infusion, the expected time, right, this is the mean time. The mean time is the expected time. It remains low, right? I mean, even though for the other three routes, except for the intravenous infusion, right, the rest of the routes, the mean expected time gets higher as the rate gets lower. In fact, you see lots of these, right? Here, you see it's getting a lot, except for this intravenous infusion, the rate gets kind of steady, right? I mean, these probably are exceptions. So, I mean, these are some of the insights that you can draw by creating new variables and seeing how that makes sense, right? I mean, so this is an overall idea of doing data science using some of these operations. Okay, so today I just wanted to make a very basic, introduction to data science. But there are so many. Yes. Yeah. So yeah. So I mean, this is the, and this could be done. There are several, like KNIME is another tool that can do all these things on a more graphical fashion. I was thinking of introducing that, but I don't think we'll have time for that. But I would have ideally liked that we all practice this to get a sense of doing data science. Yeah. So I'll take questions. Yes. Yeah.
So my question is, where's the science in the sense that, this is exactly the postdoc whatever,
Right.
and there's a metric that goes with creativity and time. And so if there's certain data sets that are common, I would imagine you can run an algorithm that would easily identify certain types of trends and visualize it for you. There's not really a, doing this by hand is kind of coding that needs to be, I feel like it can be done I have a hard time understanding the field itself of data science, where we actually bring that.
Right. So one of the key things that I would say, at least in this exercise, is that the mutate variable that you created a new variable called expected time, right? It is not there in the original data. The creativity comes there of how you can actually make meaning out of the existing information that you have. So, I mean, it's an art actually. It's more than a science. I would say that the science part of it could probably come when you have. That's where the domain knowledge is important. Let's say that you have a biological data, like let's say that you have a gene expression data here, right? You have tons of genes, and you can actually see this can be easily extrapolated for the gene expression data, right? And so there, how do you make meaning? What does it make sense to have the sum of two genes or something like that? It doesn't make any sense from that perspective, right? But it's highly domain specific when it comes to science part of it. But when it comes to analysis and extrapolation, I don't think a machine could just go ahead and do and create a new variable on its own, right? I mean, that's where the key uh, uh, aspect of data, yes, well, data science comes in, like, you how do you make sense? I mean, can you make a new variable and then see that if there is something information hidden in that data, right? So that's where that part comes in.
I imagine as through progression, so this new variable, it comes from two ordinary
Mm-hmm.
upstream variables, that becomes the paradigm. So then you can go through that and given an algorithm such that this new variable is now standard practice for updates for
Mm-hmm.
aircraft.
Mm-hmm. 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 Right.
And I'm not sure
Like, I mean, that's why I said, I mean, this will not, so that's why it's very difficult to organize a course in data science, because it's highly domain specific. Your question that you may want to understand, you may want to ask some questions pertaining to a particular field that you are in, but some of these things, right, like the select operation or a mutate operation or a group by operation, it's standard across all fields that you go in, right? I mean, how do you manipulate the data, right? And that's where I mean, how do you mix and match things to do things, right? I mean, that's where one can actually the data science, right? I mean, as you're asking, I think more in the statistics aspect of it and things like that. That's probably not what data science can do, but it can help you understand the data better, right? So, yeah, go ahead. Right, right. I mean, yeah, feature selection, right? I mean, some of the things machine can do, like feature selection, is a very tough problem. Like for instance, if there are 10 variables, right? How do you choose the best 5 variables? Tell me. No, there is an algorithm, absolutely. One of the things, right, one of the neat ways to do is try to find the correlation between the columns and find the least correlation between the columns. You don't want to take two same values again and again, right? So there is a method, there is a science in doing it. You find the correlation between the columns and find those columns which are less correlated. So it will give you more data, right? So this is a feature selection methodology. Yes.
And it's based on statistical significance. We did not touch on that. So I think in box plots and other kind of analysis, you do get an error bar, DNR, where you know what's going on in terms of variation.
Mm-hmm.
But like you said, if you have 10 variables, 16, 16, 22, you get probability.
Mm-hmm.
Which are like more close to the top, that you predict to happen or something like that.
Mm-hmm.
So when do we get to the statistical significance part in this?
You mean p-values?
Yeah,
Well, you can actually, if there are categorical variables, you can do lots of statistics on it. I mean, that's actually the initial part of my course is designed to be statistics, doing PCA, doing ANOVA, and all these statistical techniques on first few things. I mean, yeah. So that's one aspect of doing. Actually, that comes in the model and program aspect of doing data science. Actually, this book talks about EWPM paradigm: explore, wrangle, model, and program, right? And then communicate. So I started with the communication aspect of it, but you can start, I mean, the model and program, modeling, right? That's where you find the statistics. And actually here too, you can, the summarize, right? You can find the statistics of it and you can find the factors and you can do an ANOVA, whatever that you want to do in here. So yeah. So yeah, I mean, yeah. Oh, you mean the size of the data? I mean, for instance, this data is like, I think it's about, yeah, something like that. I mean, yeah, you can actually do pretty good in R. For me, I only, there is, so, databases, PostgreSQL and MySQL databases, actually, I'm covering that as a part of the course as well, where you can actually select some percentage of the data. If the data is huge, like this data, right? This database, this runs on the database in PostgreSQL, not on this computer, but I have a separate database for this. It's like the total amount of data is like with the sign, the heartbeat signals and stuff like that, it's some crazy terabytes. I think 4 terabytes or something like that. I can actually extract. There is a R PostgreSQL connection that you can connect to that database and select only some percentage of the data and then do analysis on it. That's possible. If it's a data is huge, you probably want to take a random sample and then do the analysis on it. That's the best thing that I could. Do. But there is also R server edition actually that you can.
Have a use it and you can run it on our cloud.
Right. Yeah. I mean, yeah, the R Studio is amazing. It has like you can run online, and this is a standalone version. You can have a R server, R Studio server version. That's also free, I think. Right, and that can actually, you can have the data in cloud and you can get back to it. You can sign on and off. So that might be the best actually. Oh yeah, I can send that. I can put it on. Yeah. Sure. So this data, yeah, it's already there on GitHub. Yeah.
I think the one that we downloaded, it is my data. So we just named the data as my data.
No, I can send you the links. You all received my email, right? Okay. So I have your emails. I can send that to you. Yeah, sure. Yeah, definitely. I can send it as an attachment. Yeah. Yeah, so I'm so sorry. Yeah, today, I mean, the network was crazy. I don't know what's happening. We should probably, usually it should, then the guest
Worked
net.
out okay, actually.
Yeah,
Eventually.
I mean, the R, the guest should technically work, but it didn't for some stages. Oh, no problem.
Very
So,
much ready for someone who knows to